Hello everyone, I hope you are doing well. Today we want to solve this double integral of x over y e to the power of y dA in the domain of x being between 0 and 1 and y being between x and x squared. So the first step is to draw this domain. I have that x is between 0 and 1 and that y is between x and x squared. So this one is gonna be changed into two inequalities. X has to be less than or equal to 1 and x has to be greater than or equal to 0. This one as well, so x has to be greater than y and y has to be greater than or equal to x squared. I'm gonna draw these lines. First, I'm gonna draw x is equal to 1 because of this. So x has to be equal to 1. And I know that x has to be less than 1. So we are interested actually in this region, but we are gonna highlight it later. X has to be greater than 0, which is this line. So x, not only x has to be less than 1, but it also has to be greater than 0. Now let's draw the two other lines. X has to be greater than or equal to y. So to do that, first we draw x is equal to y. This is x is equal to y. And we know that at this point, x is equal to y. On the right side of this, x has to be greater than y. So it shows us that we are interested in this region here. But we are gonna draw it later. The other curve that I have to draw is y is greater than or equal to x squared, which is this one. Again, here we have that y is equal to x squared, but here a little bit higher than that, we know that y is gonna be greater than x squared. Here it is y is equal to x squared, but here y has to be greater than x squared. Now let's see what region we have to consider. The first one is x has to be less than 1. So all this region is related to this inequality. But when we look at the second equality, it says that x has to be greater than or equal to 0. And that is here. When is it possible for x to be simultaneously less than 1 and greater than 0? That is possible if we have this region. So in this region, we see that x is less than 1, but also is greater than x is greater than 0. Now let's have a look at the second set of inequalities. First, we look at x is greater than y. So x greater than y means that we are looking at this region. And we said the reason why. Now let's have a look at the second one. Y is greater than x squared. That one is going to be this region here, the yellow part. Okay, so what is the common region that all these inequalities holds true? The only region for which all these inequalities hold true is the region here. Now we have to solve this integral for this region. Okay, so now we want to solve this integral. If we want to solve this integral, we have to first write dA. dA is basically the area of a stripe a horizontal or vertical stripe, here we take it to be horizontal, it is the area of that one. Okay, so this is dA. The area of dA is, if I draw it in a larger scale, it's gonna look like this. The width of dA is dx, and the height of it is dy. So instead of dA, I'm gonna write dx dy. Now I'm gonna add the limits. So for the outer integral, which means the integral that I write first, I usually write the variable for which we have constant limits. Here we have, for x, we have constant limits of 0 and 1. So here I'm going to write x from 0 to 1. And for the inner integral, I usually write the limit for which it includes variables. So I see here that y is greater than x squared, and it is less than x. Y is greater than x squared and y is less than x. I've written them here. Now I'm going to write x over y e to the power of y dx dy. Now pay attention, since the outer integral, in the outer integral x is the variable, I have to change the order of dx dy. So first I have to write dy and dx, and then first I have to take this inner integral, and then I have to take the outer integral. Let's continue. So x from 0 to 1, and I'm gonna take the inner integral. So when I want to take the inner integral, the variable is y, and x, it means that x is a constant, so I take x out of the integral. Y is from x squared to x e to the power of y over y dy, and then I have dx. Okay, so if I want to take this integral, it's gonna be a difficult one, because here, although I have like a single integral, I see that taking the integral of e to the power of y over y dy is gonna be a very difficult task. It means that I have to change the order of the limits. So the limit I had was related to this horizontal stripe, that y was between x and x squared, sorry, this vertical stripe. So it was related to y being less than x and y was being greater than x squared. I saw that the integral that I have in the end is going to be a difficult one. So what I'm going to do now is that I'm going to take the integral for horizontal stripe. So let's do that next. If I, instead of having a vertical one, if I have a horizontal stripe, I see that on the right side I have y is equal to x squared, and on the left side of the stripe I have that y is equal to x. Okay, so in this stripe I see that the x value of all the points in this stripe has to be less than the x value of the right side. What is the x value of the right side? That is square root of y. So x has to be less than or equal to square root of y, and all the x values in this horizontal stripe has to be greater than the x value of the left side of this stripe, which is y, right? And I also have that y has to be between 0 and 1, and now I'm going to rewrite this integral. So I have the double integral x over y e to the power y dA. Now I'm going to add the limits. As I said, I add the limit which has constant values for the outer integral, so y is between 0 and 1. and x has to be greater than y, and x has to be less than square root of y. And instead of dA, I have to write dx dy. As I said, first we have to take the inner integral, and then we have to continue to the outer integral. So first I'm going to take the inner integral, that is going to be from y is equal to 0 to y is equal to 1. When I want to take the inner integral, the variable is x, as I can see here. So it means that all the y values are constant. It means that I can take everything which is in terms of y out of the integral. So I have e to the power of y over y, the integral of x from y to x to square root of y, and what remains inside the integral is x dx, and then I write dy. So what we have to do is basically we have to take this integral now. So we are going to write it as y, the integral of y from 0 to y is equal to 1, e to the power of y, y. Okay, what is the integral of this orange part? That is the integral of all of x. So the integral of x is going to be half x squared, x being from y to square root of y, and then I have dy. I'm going to write the white parts again. So y from 0 to y is equal to 1, e to the power of y over y. And now I'm going to substitute square root of y and y in x. So it's going to become half square root of y squared minus half y squared dy. And now I'm going to simplify it. So y from 0 to 1, e to the power of y, y. And then I factorize from these 2's here. So those 2's come here, and then square root of y squared is going to be y minus y squared dy. I'm going to factorize from y in this expression. So I have y from 0 to 1, e to the power of y over 2y, y, and then 1 minus y dy. Let's continue in the next page. So this is the integral. I see that the y's cancel out, so I can remove it from the integral. Now I have this integral. If I expand this, so it's going to become half the integral of y from 0 to 1, e to the power of y minus the integral of y from 0 to 1, y e to the power of y. So the first integral is a famous one. So the integral of e to the power of y is going to become the same. So it is e to the power of y. I'm going to also put the limits, y from 0 to 1. And I'm going to write the second integral as it is for now, y e to the power of y. And now I'm going to first simplify the first part. So it's going to be e to the power of 1 minus e to the power of 0 minus the integral of y from 0 to 1, y e to the power of y, and then dy. E to the power of 1 is simply e, and e to the power of 0 is 1. So if I calculate the integral, I've solved the problem. So let's keep this expression on the top side of the page. If we call the integral we have in the question I, let's call this one integral j. So integral j is y e to the power of y. And we can solve this problem by the method of partial. So I can basically solve it by the method of integral by parts. I'm gonna call this part u. Sorry, I forgot dy here. And I'm gonna call this one dv, and we know that integral of u dv is uv minus integral of v du. So if u is y and dv is e to the power of y dy, from here I have that du is equal to dy, and from here we have that v has to be e to the power of y. That means that this integral is, as I said, uv minus the integral of v du. So I'm going to write u is y, I'm going to write it, so y. And then I have v, so I have v here, that is e to the power of y. And then I have minus the integral of v is here, e to the power of y. And then I have du is here, that is dy. So integral of j is basically given here. Now let's continue with this integral. So it's gonna be y e to the power of y minus, what is the integral of e to the power of y? That is simply e to the power of y. So if I put the values in, j is gonna be y e to the power of y minus e to the power of y. Looking at these values, y is equal to 0 to 1. I'm gonna substitute them here. So y from 0 to y is equal to 1. That is gonna be 1 e to the power of 1 minus e to the power of 1 minus 0 e to the power of 0 minus e to the power of 0. That is gonna be e minus 0 plus e, which is in the end equal to e. So now instead of j, I'm gonna write the integral of j, I'm gonna write e, simply e. Let's continue this integral in the next page. So again, as I said before, instead of j, we are gonna write e. This is the answer to this problem. So it's gonna be e and e cancel out. And finally I have minus half. And this is the answer to this question. Thank you very much for your attention. If you have any other questions, please let me know. I will answer your questions if you write them in the comment section.